All right, hello everybody. Today we are going to be talking about finding equations of lines. And the reason for this is the word problems like the ones that you're going to see here and the ones that show up in everyday life. The first one we're going to start with is when a diver descends in a lake or ocean, pressure is produced by the weight of the water on the diver. As a diver swims deeper into the water, the pressure on the diver's body increases at a rate of about 1 atmosphere of pressure per 10 meters of depth. The table and graph below represent the total pressure, which is represented by Y, so I'm going to stop and write total pressure, so I know what Y is, on the diver given the depth X in meters, okay? And I'm going to stop and I'm going to write depth for X, so that I know what these X and Y represent. So I've got depth and total pressure, and you should have on your note sheet as well. This problem makes sense. If you've ever gone into a swimming pool, even going down a couple of feet, you start to feel a lot of pressure on your head. This is exactly what happens to divers. They need to figure out how much the vast pressures of the water, when they start going much further than just a couple of feet down, how much pressure they're going to deal with, and so how much they need to compensate for that. Okay? We have a linear equation. For no other reason, we know that because over here they show a line, and a line is what we get when we graph a linear equation. Okay. What we need to do is we need to find a formula for this linear equation in order to be able to answer these next two questions. How much pressure is exerted on the diver at 17 meters of depth? How much must a diver who has how deep must a diver be who has 5/2 atmospheres of pressure exerted on him? Okay, we're going to go to the next slide to create the equation so that we can then answer these questions. Okay, our key, the thing that we are always looking for, or almost always looking for when using linear equations, is this formula right here. This is our This right here is our standard slope-intercept form of an equation. Slope-intercept form, not standard form. This is the easiest equation to use, and we always want to try to get here if we are not asked to do something else. Okay, just take a second to show what all these things mean. I know this is review. M is going to be your slope. B is going to be your y-intercept. Now, those are the easy ones. The ones that people sometimes mess up on are y and x. Y is always going to be your dependent variable, and x is always going to be your independent variable. For my problem, which I have reproduced here, I am going to label what x and y are so that I do not forget. X, my independent variable, is the part that I have control over. In this situation right here, we only have two things to choose from. We have the total pressure, and we have the depth. I do not get to pick how much pressure the water is putting on me. What I do get to pick is how deep I am. So my independent variable is my depth, and my dependent variable is my pressure. Notice I am writing this down, and you should be as well. Writing what x and y represent is a good way for me not to make mistakes. All right, let's see what the next slide is. Okay, so now it's just a matter of using our formula, y equals mx plus b, to create our equation. Y equals mx plus b. Well, my m is my slope. Do I know that? Maybe. Well, it doesn't look like it yet, right? But my slope, as I'm going to write down right over here, slope is equal to, remember, my change in y divided by my change in x. I can come up with this right from the formula that was given to us. The pressure increases 1 atmosphere of pressure for each 10 meters of depth. So my rate of change is equal to the change in y, which is the total pressure, 1 atmosphere per meters of depth. That's my change in x. 10 meters of depth. Okay? So change in y divided by change in x, or 1 atmosphere per 10 meters, that is my slope, also known as rate of change. So once I have that, it's not too hard from the graph to find my y-intercept, which is just right there where it intersects the y-axis. And so I come up with the equation y equals m, which is 1 over 10 times x plus b. Plus b, which is 1 from the graph that I see. Okay? Once I have that, I can then go back to the previous slide and answer these questions. Or actually, I wrote it on the next one, and I made a little bit of a mistake here. It's 1/10 x plus 1. How much pressure is exerted on the diver at 17 meters of depth? Well, we just use this formula, and we figure out which one is 17 meters of depth. Was depth my x or my y? Well, luckily I have that written down on the previous slide. X is my depth. Okay? So I'm going to just replace my depth with my x, and so I have y equals 1/10 x plus 1. Y equals 1/10 times 17 plus 1. And so I get y equals 17 over 10 plus 1. Or y equals 1.7 plus 1 equals 2.7. So he's going to have 2.7 atmospheres of pressure. Now that's just one atmosphere is the amount of pressure that you normally feel at sea level. So 2.7 per atmospheres is like twice the amount of pressure that you're used to having on you. Or, almost 3 times as much pressure as you're used to having on you. So it's already going to be quite a big difference in your perception. The next question, how deep must a diver be who has 5 halves atmospheres of pressure exerted on him? Well, we start with the exact same formula, y equals 1/10 x plus 1. However, the only difference here is that we have a different piece of information being given to us. 5 halves atmosphere of pressure. Well, pressure was my y variable, if you remember. So instead of replacing x this time, to find the answer to this question, I'm going to replace y with 5 halves. So I get 5 halves equals 1/10 x plus 1. And then I'm just going to try to solve for x. First thing I do is subtract 1 from both sides. I'm going to subtract 1 over here. I'm going to subtract 2 over 2, which is another name for 1 over here. And so I get 3 over 2 equals 1/10 x. Now if I multiply this side by 10 and this side by 10, these 10s are going to reduce down to 1, and so I do not have to consider them anymore. And I have x is equal to, well, I've got one simplification I can do before I multiply across. 10 and 2 have a common factor of 2, so I divide that out. I get 15 is equal to x. Okay, so what does that mean for us? How deep must a diver be who has 5 halves atmospheres of pressure? He must be 15 meters deep. This is the reason we are doing everything we are going to do for the rest of the chapter, really. We are trying to answer problems that come up in the real world, and the easiest way to do that is to come up with an equation like this, so that I can quickly plug in answers like I did right here, and plugged it in there and there, and that gives me my answers much, much quicker than if I was just looking at a word problem and trying to figure out what's going on and possibly getting confused. Okay? Now let's do a couple more. It will sometimes be one level of abstraction up, meaning that we will have less words and more of a just telling you what to do sort of thing. You need to know how to do both. In this problem, you may be given something like this. Find the equation of a line that has a slope of -4/5 and a y-intercept of 8. So we have to think to ourselves, what is given to us and what do I need to do? Given here is slope and y-intercept. This this should tell you right away you're going to use slope-intercept form. Which is y equals mx plus b. If that's y equals mx plus b, then all I need to do is replace the information that I need to replace every time, which is my slope and my y-intercept, and I have my equation. Y equals my slope, which I am told is negative 4/5. So y equals negative 4/5 x plus my y-intercept, which I am told is 8. So plus 8. There's my equation. I always, always, always leave x and y as x and y so that I have an equation that means something. If I replace those with numbers, there's no power in it. Now all I have to do is answer these questions. Find the value of y when x is 10. Y equals negative 4/5 times what x is, 10, plus 8. I can reduce this. The 10 and the 5 have a common factor of 5, so 1 and 2. I am left with y equals negative 8 plus 8, so y equals 0. Next one, find the value of x when y is 12. Same formula, y equals negative 4/5 x plus 8, but now I am replacing y instead. 12 equals negative 4/5 x plus 8. Solve for x, so subtract 8 on both sides. 4 equals negative 4/5 x. To get x by itself, I need to multiply by the reciprocal by negative 5 over 4. Because the 5s will cancel out, the 4s will cancel out, and then negative times the negative will give me a positive. And so I'm just left with positive x over here, but then I have to multiply by 5 over 4 negative here. The 4 and the 4 will reduce to 1. And so I'm just left with negative 5 equal to x. Okay, we're going to move on for time's sake. Write the equation for each line that is graphed. Now, the given information looks a little different here, but from any graph, you can easily see the y-intercept and your slope, because it's rise over run. So the easiest thing to do is write these in slope-intercept form. Now, what is my rise on this example 1? Well, I'm actually going down 2 and over, or I'm sorry, I'm going down 4 from here down to here is down 4, so that's a rise of negative 4, and then I'm going over plus 2. So my rise over my run is negative 4 over 2, which is equal to negative 2. And my y-intercept is very easily sorry, I was just checking the graph to make sure that I had not read that wrong. It's a little blurry on the smartboard where I'm trying to use it. I'm going to try to fix that for just 1 second. Oh, much better. Okay. The y-intercept is where it crosses the y-axis. That is right here, which is at 4. So my y-intercept equals 4. My slope equals negative 2. And so all I have to do is plug in slope and y-intercept to my formula. I get y equals negative 2x plus 4. Same thing over here. My y-intercept is very easily seen to be 4. Same y-intercept, actually, equals 4. But my slope is different now. My rise over my run is equal to how far I'm going up divided by how far I'm going over. So my rise between this point here and this point here, that's what I want to consider. My rise is 2. I go from 4 to 6, so my rise is 2. And my run, I go from 0 all the way over to 10. So my run is 10, and so 2 over 10 is another way of saying 1 over 5. And so all I have to do is replace 1 over 5 and 4, and I get the equation y equals negative 1/5 x plus 4. We need to move on. Write the equation of the line with slope 1/2 and through the point 2, 5. So what am I given here? I am given a slope and a point. This is a little different. I always want to write down to myself what I am given, slope and point. And then I need to figure out how to do this. There are two ways to find an equation when given the slope and a point. First way is by using the point-slope form, as the name suggests. You've got a point, you've got a slope. This is the equation for your point-slope form. You can simply replace the information and call it good. Y minus, well, what's y1? I have my point that is given to me is going to be x1, y1, and so my y1 is 5. That is going to equal my slope, which is given to me as 1/2, times x minus, what's x1? That's the x-coordinate of the point then given, so minus 2. I am done, but sometimes I want it in y equals form, so you could add 5 to both sides and distribute to get y equals 1/2 x, 1/2 times -2 is -1, and then plus 5 gives you y equals 1/2 x plus 4. That's it in y equals form, or otherwise known as slope-intercept, or slope-intercept. This would be it in point-slope form. Okay. The other way you can do it is by using the other formula that we've already used, and remember I told you is so much more useful for most things. You can just use y equals mx plus b form. Only problem is we are not given our y-intercept, so we'll need to find it. Let's see how this works. We would do y equals, I know my slope, so I'm going to replace my m with my slope. Y equals 1/2 x plus b. I'm still stuck because I do not know what this b is. However, I have this point 2, 5 that is given to me. So very, very, very temporarily, I can replace x and y with 2 and 5 to figure out what b is. And once I know what b is, I then put it back into y and x. I do not leave it as 2 and 5. So let's see how this works. 5 gets replaced for y. X gets replaced with 2. And we still need to solve for b. Well, this is saying that 5 is equal to 1. 1/2 times 2 is 1, plus b, meaning that b must be 4, because 4 plus 1 is 5. Now that I have b is 4, I do not call myself done until I do this final step. Y equals mx plus b. So y equals my m, which is still 1/2, x plus 4. Notice I still have y and x in my equation. They must be in my equation, or I do not have the equation to a linear relationship. Okay? Notice both ways we get the exact same answer. This way, you can continue to use y equals mx plus b form, and it is much, much easier to remember, but also more interesting visually, I think. Okay, I'm going to leave this one for you to do, but I'm giving you the answer down here on the right. You must show your work. You can do it either of the two ways we just discussed. Final thing we're going to do today, write the equation of a line through 5, 6, and 7, 1. Well, what am I given here? I am given 2 points, and that's it. So there are 2 ways, again, to do this. There's only one. The good news is there's only one new step, however. The new step is we always need to find the slope. We don't have it, but we do have our slope formula. So step 1, find slope. Step 1, find slope. Whichever way you want to do the rest of it, that's your first step. Remember your slope formula equals y2 minus y1 over x2 minus x1. And so we get, so we have to label these 2 points with x1, y1, x2, y2. I'm going to label the first one x1, y1, the second one x2, y2, just to be boring. Okay? And now y2 minus y1 is 1 minus 6 over x2 minus x1, 7 minus 5. This is negative 5 divided by 2, and so my slope is negative 5 over 2. That is exactly the same if I was going to do it over here using slope-intercept form, so I'm just going to write the slope as negative 5 over 2. Finally, I need to do step 2, which, good news, same as previous slide. Because what you now have is you have a slope, which is -5/2, and a point. Either one you want to use. I would pick 7, 1, because 1 usually is easier to work with. You have a point and a slope, so what I'm going to write, given, is slope equals -5/2. Point is 7, 1, and I'm going to repeat the same thing that I did in the last slide. I'm only going to do one of them. I'm going to do the slope-intercept form, y equals mx plus b. So y equals -5/2 x plus b. Then I am temporarily going to replace x with 7 and y with 1. So 1 equals -5/2 times 7 plus b. I need to solve for b. And so what I'm going to do, is -5/2 times 7 is just -35/2. So 1 equals -5/32 plus b. I'm going to add 35/2, add 35/2, and to get a common denominator, I'm going to turn 1 into 2/2. So I have 2/2 plus 35/2. 37/2 is equal to b, and so my formula is y equals mx plus b. Y equals -5/2 x plus 37/2. I am done. And so all I did with a 2-point formula, or given 2 points, I first find my slope, and then I do the exact same thing as when I have 1 point and a slope. This one is for you to do. I have given the answer at the bottom, but you need to show your work, and we are done. Thank you so much.